what's up? Welcome back. Moving on to the next example, dealing with piecewise functions. So this is a popular kind of question that comes up. What we're going to have to do is find constants, in this case m and n, that's going to make each of these piecewise functions continuous here. So notice that we have two different scenarios. Now, notice that in the first one, there's only one constant to solve for, right? Or we're only going to be solving for this m value over here. However, as you'll see, when you run into these kinds of questions, sometimes you'll have one constant to solve, sometimes you'll have two. So notice in part B, we're going to have two constants to solve. So I wanted to put both scenarios here in this video so you could see how they work. Now, just in general for piecewise functions, if you remember from the overview video that we did, we said that a piecewise function is going to be continuous if the y value at the meeting point is going to be the same. So if you remember when we were graphing them, we were making the 2 or sometimes 3 table of values, right? And the tables of values both had the meeting points. And if the y values at those meeting points on the two tables were the same, we knew the function was continuous. If they were different, it was discontinuous. So same thing is going to apply here. So basically what's going to happen is at that meeting point of x is equal to 3, right? Both of these pieces here, they're meeting at an x value of 3. At an x value of 3, these two functions have to have the same y value, right? At these, so this is like a downward line. And then this is going to be a parabola that's opening up like this, right? So at that x value of 3, both of these pieces have to have the same y value. And if they have the same y value, then they're going to be continuous. And so what we could do is make these equal and then just plug in 3 and solve for the remaining m value. Right, so we would end up with what? Negative 8 is equal to 18 plus m. And so m is going to be negative 26. So that's going to be the solution for part A. So if m is negative 26, so if the quadratic is 2x squared minus 26, if you were to graph this, you would notice that this piecewise function would be continuous, right? At an x value of 3, the line is going to have a y value of negative 8. And if we plug in an x value 3 for the quadratic, it would also have a y value of negative 8. Right? So they're both going to meet at the same point. So that's the m value that's going to make it continuous. Any other m value that we would use other than negative 26 would make the function discontinuous because there would be like a break, right? So you would have the line, actually the line would have a hole, right, because it's not including the 3, and then the quadratic maybe would start above it, could also start below it, right, depending on what the m value is going to be. So any other m value other than negative 26 would make it discontinuous, and m value of negative 26 makes the piecewise function continuous. Moving on to part B, so notice that this one is going to be a little bit more of a complex piecewise function. We have 3 pieces here, 3 domains, and notice that in this case we have 2 constants to solve for, right? We have this m, n to solve for, and then the m is also over here in this third piece. However, the same intuition is going to apply. So basically, wherever these pieces are meeting at whatever x values, the y values at those meeting points have to be the same. So notice that this first piece, its domain is all the way from x values negative infinity all the way to negative 2, right? That's where it stops. And then the next piece is going to continue off from that same x value of negative 2. So notice that these two pieces over here, they are meeting at this x value of negative 2, right there. Okay, so what that means is at an x value of negative 2, these two pieces have to have the same y values. So basically, x squared minus 5m plus 5 has to equal this function over here, x minus 3. At an x value of -2, both of these functions have to have the same y values. Okay, and then notice that if we continue on with what I was saying before, so this function picks off from -2 and then goes all the way to an x value of +2, and then it ends there, and then this next piece is going to pick off from an x value of 2. So these two pieces over here are meeting at the x value of +2, which means that if this function is going to be continuous, if this piecewise function is going to be continuous, it means that at that next meeting point of 2, these two pieces, n over x minus 3, has to equal 7 over 2x minus 6n, right? These two pieces at that x value of 2 have to have the same y value in order for this function, for this piecewise function to be continuous. Now, this is not necessarily how they're both going to look. I'm just trying to show you how both of these pieces here are going to meet at that same point. At that x value of 2, they're going to have the same y value. And then from here, all we have to do is basically create two equations in terms of m and then we could do substitution and or elimination to solve for them. So for this first one, we're going to plug in -2 for the x values. So we'll have -2 squared minus 5m plus 5 is equal to n over -2 minus 3. So -2 squared plus 5, so that's 4 plus 5, which is 9. So I'll have 9 minus 5m like that. That's what the left side's going to simplify to. This is going to be over -5, like that, n over -5. And then we can multiply both sides by -5, get rid of the denominator. Another thing we could do, we could put this over 1. Cross multiply. There's different ways to simplify these, so whichever way you're going to do it, just make sure that you're getting the same answers that I am at the end. So if I cross multiply, 1 times n is n, -5 times 9 minus 5m, got to put that in brackets. And this is actually nice because we have our n isolated here. So we have an expression in terms of n that we're going to sub in here, but let's first simplify this. So in this one, we're going to plug in an x value of 2. So we'll have n over 2 minus 3 is equal to 7 over 2 times 2 minus 6m. Over here, the 2's cancel out. 2 minus 3 is -1. n divided by -1 is -n. And that's going to be 7 minus 6m, like that, right? And then, you know what, I'll just, I'm going to bring the -n over, bring these over, 6m minus 7. So now we have another expression in terms of n, so now we could basically make these equal, or it's like I'm taking this expression and then plugging it in for this n right here. Okay, so again, whichever way you do it, just make sure you're going to get the same solution. So we'll have equals -45 plus 25m, like that. So if I bring the -45 over, -7 plus 45 would give us 38. If I bring the 6m over, 25m minus 6m is 19m. So notice that m is basically going to be 2, right? If we divide both sides by 19. And then I could take this m value of 2 and plug it into either one. I'll just plug it in here. So we'll have 6 times 2 minus 7 is equal to n. So 5 is equal to n. And those are the solutions. So m is 2, and then n would be 5, right? So those are the constants. If you plug them back into the original function, that would make that piecewise function continuous, because at the meeting points of -2, the two first pieces would have the same y value at that x value -2, and then at the x value of +2 at this next meeting point, the second and the third piece would have the same y value with these constants m and n. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.